Without beer, we wouldn't have modern physics. To find out why, we have to go back in time. It's the early 1800s in the city of Manchester, which is booming thanks to the Industrial Revolution. Cotton factories are springing up everywhere. The living conditions are appalling for many of the workers. And to help them with that, one family had a brilliant idea. We'll sell them beer. William Jewell from Derbyshire opened a brewery in Salford on the outskirts of Manchester, and the business did so well that by 1818, when his grandson James Prescott Jewell was born, they had enough money to send the young lad to be privately educated. As a young boy, James Jewell had a great interest in scientific experimentation, but not so much in health and safety. A mishap with gunpowder on one occasion meant he blew off his own eyebrows, and on another occasion, he gave a servant girl powerful electric shocks and asked her how she felt until she fainted. Now that's not a story that puts him in a very good light. Now when he reached adulthood, James Jewell took an active interest in running the family brewery, and he became particularly intrigued by a very interesting question. How could you save on fuel costs? Now the brewery used a steam engine to run its various pumps and stirrers, and James wondered if the newly invented electric motor might save them money. So he started doing a series of experiments to find out. And the short answer was no, it didn't. Jewell's batteries worked by dissolving zinc in acid, but the amount of zinc that was consumed as the electric motor worked was far more expensive than this amount of coal the steam engine burnt when it did an equivalent amount of work. But the process taught James a very important lesson. He understood firsthand that mechanical work, electrical energy, and the heat from the boiler of a steam engine are all aspects of the same thing. And over the next few decades, Jewell did a series of experiments funded by the brewery profits, which established that that thing is what we now call energy. Jewell was one of the key people who came up with the idea we now know as the first law of thermodynamics, or the conservation of energy. This is the idea that there is a fixed amount of energy in the entire universe, and though one form of energy can be turned into another, the total amount is fixed. It cannot be created or destroyed. It can't be overstated how important this idea is. The modern economy runs on it. Our homes are full of devices that turn one form of energy into another. Light bulbs turn electricity into light. Our boilers turn the chemical energy in gas into heat. Our cookers turn electrical energy into heat. Everywhere we go, we can see energy being changed from one form into another. And it's crucial to the way we got to understand the living world. We now know that plants take the energy in sunlight and store that in sugar, and that we can consume that sugar and release that energy to power our bodies. Speaking of sugar, like all foodstuffs, its label tells us how much energy it contains. It says here that 100 grams has 1,639 kilojoules of energy. Joules, named after James Jewell. Of course, in Britain, we mainly count the energy of food in calories, which is actually a unit invented by a Frenchman. Ironic, huh? But it's not just energy conservation that beer gave us. It was also refrigeration and low temperature physics. You see, lagers like this have to be fermented at temperatures below 5 degrees Celsius. And in the 19th century, German beer makers funded refrigeration technology so that they could make their beers all year round and not just in the winter. In the 1890s, Guinness became interested in the liquefaction of carbon dioxide. That led to low-temperature refrigeration technologies, which in turn paved the way for the modern gas manufacturing and storage industry. So next time you're in a hospital and you see a cylinder of oxygen, think beer. So I hope I've persuaded you that physics owes a great deal to beer. Anyway, I'm off to the pub to celebrate science.